just getting back to the the Netflix example that you gave, where effectively you saw that just basically by what people were looking at, the timing and things like that, how they're able to connect these two data sets. You can imagine that when you bring IP addresses into this, where that's just a massive, presumably the challenge just even disappears, where you don't even have to, the technical challenge of mapping these things disappears even more. So effectively, any company that is good, for example, Google Analytics, which they track your IP address, across different locations, and that's where they derive a lot of their value. That effectively, these problems can become trivial, technically speaking, with just a few extra bits of information. Is that correct, or is that tinfoil hat?
No. I mean, of course, the big companies know everything about but even your telecom provider, every time you make a phone call, every time you use an app and search on the internet for anything, it doesn't just happen, right? Your phone sends a signal either to the closest Wi-Fi box or to the closest cell tower or something, saying, hey, literally get HTTP get me, the information from this URL. And even if that's totally encrypted, they need to know where to send it to, so they can route your traffic through the internet.
Mm-hmm.
So of course they know exactly where you are. Just think of your telecom, right? Because you're connecting to their cell phone towers, of course they know where you are. They have to, otherwise they wouldn't be able to you wouldn't be able to receive a phone call, right? So that they have to be able to do that to do their job. They need to be able to connect you to the internet. So they have to be able to route your traffic. They have to be able to route all of your phone calls, all of your text messages. You're literally paying them every month to do that for you.
Mm-hmm.
Now, your hope is that what they do with that information is kind of aligned with what you would want them to do with that information. And they don't kind of go off the track and start using it for monetizing you in other ways and stuff. And I think when products are free by profitable companies, it's usually because you were being monetized in one way or another. So yeah, one statistic that I thought was really interesting was, if you were to read all of the data usage, so user agreements of all of the different services that you use online per year, it would take you 76 hours per year. So that's a full-time job for 2 weeks for a lot of people.
Mm-hmm.
You just read through all of those T's and C's that you consent to when you go to use a particular website. So we're signing up and letting people use their data all the time. And I think that puts a big trust in these companies to actually, use that data in kind of an ethical and secure and safe way.
Hi everyone. Today's guest is Jack Fitzsimons, Head of Technology at Oblivious AI. Jack and I are academic half-brothers by our shared supervisor, Steve Roberts, at University of Oxford, and I've always been impressed by Jack's insights and raw intelligence within minutes of meeting him on a train ride up to Sheffield, if you remember that, Jack. And since then, my conversations with Jack have always filled me with this sense of adventure, and I've wanted to share this with the listeners over a series of conversations. So this is the first one. This, for those listening carefully, this is going to be the second of hopefully only 3 episodes in which my voice is completely shot. But I hope that you can all enjoy this as a sort of a contrasting duet between my cacophonous croaking and Jack's lyrical Irish accent. So, Jack, welcome to the show.
Thanks very much, Glenn. Not sure if I would agree with all of those compliments that I've received, but I did very much appreciate it.
I actually remember the first thing that when we were on that train ride up to the Gaussian Process Summer School up in Sheffield, and we were essentially talking about essentially some of the computational burdens of Gaussian processes. And I won't go into the details too much, but essentially you said, isn't X just Y in the kernel space? And I thought about it, and it's yes, it absolutely is. And why hadn't I thought of that yet? And since then, I was just that was I've always just enjoyed your insights and things, and I do believe that you bring a high gear I view myself as someone who can pedal a low gear very quickly and continuously, and I view you as someone who has been blessed with a high gear that you can really turn the crank on some things. And so that's why I've always enjoyed it.
I'm really not sure about that, but thank you very much. Just try to keep it simple.
Keep it simple.
Try to understand what's going on and go from there.
Well, it's also just
Thanks,
been, I do very also think that I always end our conversation feeling very excited about what's possible with the various projects that you've been involved in. So I guess today we're going to be talking about privacy and privacy enhancing technology. The data sciences essentially come along with a massive proliferation of data, and not all that data has been very useful and it's been very profitable, but at the same time, it also opens up enormous opportunities to exploit in ways that we may or may not want. But privacy enhancing data. So I think this is nice for people in the statistical and data science range, because effectively what we're talking about is the real type of technology that can be used to exploit this data, and also how we can be using technology and data and statistical expertise to start protecting people again in the way they might want. So privacy enhancing technology and privacy. What is your definition?
Yeah, well, that's very good question. So privacy enhancing technologies, I mean, kind of self-explanatory to some degree, does what it says in the tin. Technologies to help enhance privacy, right? But what do we actually mean by that? So, I mean, maybe it also makes sense just to explain like why I was interested in this area in the first place. But I come from, as Glenn said, we're academic half brothers. So I come from like a machine learning and statistics background. And one of the challenges I always found was like, unless you use data sets that were like maybe online and like publicly available, like actually getting your hands on data is just like really difficult. Like even when you're inside a company, and you might even have like senior title or something like that, but just to actually do your job, sometimes you need access to data that like some other team members just not prepared to give you or something. It creates like a lot of challenges, and half the time you end up wasting time. Like projects get like redlined and don't go ahead, or like suddenly you're forced to go to someone else's office and have like some like terrible computer with like massively outdated software to try to like start a project, and you've just like wasted your entire day on it, and nightmare. So I got really interested in like ideas of like how technology could be used to like alleviate some of these challenges. And privacy enhancing technologies, as kind of a catch-all title, basically are a set of technologies that help manage privacy, manage how data is used basically throughout its life cycle, so that you can still use it and create value out of it, but you keep that data safe throughout its life cycle. So typically speaking, when we talk about pets, let's give it its privacy enhancing technologies, pets, we're kind of talking about two categorizations. So we talk about like input privacy and output privacy. So I guess most of the listeners will be familiar with like a function or a model or something like that, right? And typically you have some inputs coming into that and you have some outputs coming out of that. So let's just think of like a simple example. So imagine I have a bunch of listeners on my podcast that I don't have, but if I hypothetically had a podcast, and so does Glenn, and we're like, hey, let's do like a collab together, and we wanted to look at the intersection of who our shared listeners are, or like what are their demographics, what are their shared interests, etc., so that like we could make content that would like best appease them. Well, like our first concern would be maybe how do we, if I don't want to tell you who my viewers are, you don't want to tell me who your viewers are, imagine it's customers or something, so it's private. Like how do we actually bring those two lists together in order to be able to do some sort of like joins or something, or like work out who that subgroup is, etc.
I will never give out my list of all 10 of my listeners.
yeah, exactly. But like, basically, how do we bring data together from different parties, or maybe even from a single party, use it for a specific use case, and give a guarantee that it is not being used outside of the like purposes which you're expecting your data to be used for, right? So that's kind of like the space of input privacy. And there's different ways of doing that, which we can talk about. But the second half of it is output privacy. And so this is like, okay, we have the output from this function now. And how do we disseminate it? How do you give it to someone in such a way that they can't reverse engineer the original inputs from it? So for example, imagine you knew all of the salaries or something of all of your listeners, right? And you had, at the time that this came out, you have 1 million subscribers or something, and you give out your statistics, and the next day you give them out again, and your subscribers grew by 1, and you told the average salary of your subscribers on the first day, and then the second day, like somebody could actually work out what that new person who subscribed to your salary would be, right? And so that could potentially leak information about an individual which they hadn't really signed up to, or it could be if you were looking at like employees, like salaries, or it could be like purchases, like people making transactions on a website, or it could be whatever. You don't want that if you're like publishing a report, or if a third party is getting access to that information, that they can reverse engineer the original inputs. And so there's obviously different ways to go about both. When it comes to output privacy, the kind of classic that I think a lot of statisticians will be familiar with is like data disclosure controls. So anyone who works in like the official statistics community, so if you work for like census, or if you work with anything like this, often you need to aggregate and bin data in such a way in order to make sure that the sensitivity of the outputs is safe enough to reveal, essentially, without reverse engineering. But there are like modern frameworks called differential privacy, which I'm happy to speak about, which is just a way of like basically adding error intentionally to outputs, so you can't reverse engineer. And when it comes to input privacy, the first one, there's different ways you can go about that too. So the kind of 3 primary ones would be like maybe find someone you trust. We bring in a third party, we give it to both our lists to them, they do the calculation for us. The second is through encryption-based approaches, so often referred to as like homomorphic encryption or multi-party computation, which are like quite basically using a special type of cryptography that preserves some structure such that the values can be manipulated without anyone seeing what the unencrypted values are. And the third option is using something that's a little bit, it's relatively new, but it's been adopted by most of the major cloud providers now, which are referred to as secure enclaves. And these are basically trusted execution environments that give you a guarantee about what the software is that's running inside of them. So I can like connect in, and through connecting to like an API running inside like a trusted execution environment, essentially I get a guarantee about what's running inside of that. If I trust it, then I'm good to upload the data. If I don't trust it, I'm not going to upload my data, basically. Privacy enhancing technologies are kind of like an encapsulation of all of these different techniques in order to bridge trust between people and to allow you to use data for particular purposes while keeping it safe while doing so.
Yeah, cool. So like, let's just say that my problem was not only trying to conceal the fact that I only have 10 listeners, but the fact that they all went broke over the course of listening to my podcast. Then which does the method, the privacy enhancing technology that I use, would that have changed? Would that have been different, say, 10 years ago versus what it is today versus, say, 20 years ago? What is, in a broad spectrum, what is sort of the history of what people have been doing? And is there a trajectory to this, or have all 3 of these options been sort of co-developed and reaching maturity at the same time?
Yeah, great question. Okay, so it's like the history has been, some of these are quite old. So multi-party computation, for instance. So this is when typically, like say you'd have like 3 parties involved or something. There's different approaches of how to do it. Like the most common is through secret sharing. So I'm going to take my data, and like every time I have a value, I'm going to split it into 2 values, and I'm going to give one to each party, and we're going to keep doing stuff like this, secret sharing, passing packets between ourselves, which ultimately give us a calculation, but no one ever sees the full picture, and because everything's split between the other parties. So these type of approaches have been around for a long time. So actually, you may be familiar with RSA, the encryption scheme. It's probably the most famous public key encryption scheme of all time, essentially. But the same people who wrote that, RS and A, they also worked on other papers that involved multi-party computation. So we're talking about encryption schemes that have been around for 20, 30 more years. However, the challenge with multi-party computation, homomorphic encryption, etc., is just that typically, because they involve like passing things between parties quite a lot, you often have quite a lot of rounds of communication, which can make things slow. And you often have quite a large sets of encrypted data that has to go back and forth. So you're sending a lot of information back and forth between the people a lot, right? And this is what makes for many problems still kind of untractable to some extent. Homomorphic encryption is typically when you have two parties, and basically I'm going to encrypt my data in such a way, send it to you, and you're going to essentially apply a polynomial function to that and send me back the result, but you can't decrypt my data in the meantime. And a huge breakthrough was through Gantry's PhD thesis back in 2009. He was a PhD student in Stanford. He's now obviously like one of the most famous people in the field. But he realized basically like the concept of homomorphic encryption was around for a while, but it was like very, very complex, and he reduced that to be more feasible for certain problems. And that really accelerated the field in that space. But the trusted execution environments, which is kind of what I work with a lot more, or secure enclaves, they've really grown in popularity over the last like 5-6 years, really. So Intel started building physical chips that supported like an actual separate portion of the chip that just was used for like secure manipulation of data, called the Intel SGX. I don't know, 5-6 years ago that came out initially, but obviously very limited, very small amounts of memory could be used, limits in terms of like what functionality you can really provide in there. And that's kind of snowballed. So new chips are coming out by many different chip providers, including obviously still Intel. And also some cloud providers have figured out ways that they can actually use their cloud infrastructure to provide a similar functionality to the end user. So this time last year, almost exactly, I think it was the beginning of November 2020, plus or minus a few weeks, AWS brought out their Nitro Enclave technology. And essentially what that is it's like you can almost create a server in the Amazon infrastructure, and they would create these documents, attestation documents, and digitally sign hashes of the program that you're running inside of that trusted execution environment. So it means you can share a Git repo, look at the code, say, yeah, this looks pretty safe for us to run. We can host it in either one of our AWS accounts, but because we both trust the infrastructure of AWS, when connecting to it, we can actually get these attestation documents. That's a guarantee from Amazon that what we're expecting to be running in there is what's actually running in there. And that can bridge trust between us. And then that's all input privacy. The second part, obviously, is output privacy. Within the official statistics communities, output privacy, has been used by census offices for like over 100 years, I think. But differential privacy was actually introduced by Cynthia Dwork more recently. And this is the concept. It's a stricter definition of what we mean by output privacy. It's basically around, can you guess whether or not a particular entry in a database is there or not based on the output that you get? And typically there's a mechanism to try to hide this by adding noise, like noise that statisticians are probably very familiar with, like Laplacian noise or Gaussian noise, to your outputs, in order to prevent the reverse engineering. It becomes like a learning with errors problem. And so you can prove how sensitive essentially the output is with respect to the inputs. If you have many outputs, you can kind of combine them together to get on like an upper bound in terms of how much privacy you've leaked over sharing all of that information. And that's like, in the last kind of decade or so has like really grown in popularity. And this has affected a whole like swathe of different fields that you'll see now at like all the top machine learning conferences. You'll hear of federated learning, distributed learning, multi-party learning, et cetera, et cetera. So all these topics are essentially just using one or multiple of these techniques in order to achieve a particular kind of ideal functionality between participants who have data, who are trying to combine it in some way in order to get some shared output, or for one party to get an output from the work.
Hey folks, we're a few minutes into the show. This is usually the part where the podcaster talks about their sponsor or something. I'm not going to do that, but I will ask two things. One, if you could leave a like or a dislike based on your preference, and also let me know what you think about this topic, and also what topics you like discussed on future episodes of the show. That's it. Enjoy the episode. Just to recap one of these main ideas, because when someone says the the key idea is X. I always think it's helpful to repeat it. So you're talking about how you don't. The idea is that you don't want somebody to be able to guess a data entry, whether or not a data entry is in a given data set. Can you reiterate that again, just so that I can start stewing on that a little bit better?
Yeah, so that's for output privacy, right?
Mm-hmm. So for output privacy.
Differential privacy essentially is the exact one that I was talking about there. And so for differential privacy, essentially imagine I have like, let's say we're looking at like people's salaries in Seattle or something, right? And we survey a bunch of people and we were to, print in the census what the average salary of people from Seattle is or something like that. Well, if the neighborhoods change year on year or something like that, and you could try to guess like what is perhaps my neighbor's salary, or like was my neighbor's salary in the like registry of people's salaries when calculating this statistic? Yes, no. And you don't want you want to be able to hide that. So any individual record or set of records associated with an entity, from the output you can't tell if that was part of the data set or not originally. And so how we hide that is by adding noise to it. You're going to add noise to the result at a magnitude that's essentially proportional to how much impact or influence any individual can have on that average salary. So if they could literally have any number between 0 and infinite in salary, then obviously you'd have to add a huge amount of noise to be able to hide that one person's salary who's like infinite. Or if like Jeff Bezos, I assume he lives in Seattle because of Amazon, but I actually don't know. If he's in there and he's like a trillionaire or something, I don't know how much he has. Obviously that's going to skew the statistics. So you'd have to add a lot of noise to make sure that someone couldn't tell whether or not Jeff Bezos is in the list of people who'd been surveyed, let's say, to get the statistic. However, for other problems, especially if they're problems people's influences are like bounded, so it's like I'm surveying a lot of people and they're saying yes or no, then the maximum impact anyone can have is like 1 in whatever the sum is, right? So it's very easy to know how much noise we would want to apply to that to make it essentially, it's the reverse engineering whether or not somebody had made a particular vote or not is infeasible for someone who's like maliciously trying to kind of understand what the original inputs were, essentially.
Yeah. And for someone, because obviously, one part of statistics that would be nice is if the statistic is correct or accurate. Is there a conflict between the idea that effectively, if you hear, here's a statistic, but we've added a lot of noise to it? What is sort of the trade-off between those things, or effectively the accuracy of the quantity that you're trying to calculate, and on the other hand, the sort of protection of data points?
Yeah, that's an area of big conversation within the community for output privacy. And like it's usually referred to as like utility versus usability. So, utility versus privacy. So, how useful is the information now that you've added noise to it, right? And it depends, right? So, the amount of noise in order to assure that you've only leaked a certain level of information, you've only revealed a certain, talk about epsilons in terms of privacy. It's just based on the definition. If you were to fix that, then the amount of noise you'd have to apply would change drastically depending on the type of statistic you're trying to perform. So, for example, imagine I was taking like KL divergences between distributions or something like that. I'm using statistical terms here based on who I'm having a conversation with. Well, I take the KL divergence between two distributions, and that value can go like minus infinity to infinity, and it's very unstable. It can like shoot off very quickly. If there's, if they deviate by even a small amount, right? It's very
As someone who has engineered features based on KL divergence, I can tell you that they will explode in a heartbeat.
Exactly, right? Yeah. So how much noise...
In my case, literally a heartbeat, but yeah, okay, go on, sorry.
Yeah, exactly. So like the amount of noise you have to put on in order to just like hide any potential issue, because it's minus infinity to infinity, it's very unstable. So you don't even have... you're going to be putting on a lot of noise. That's basically the purpose, right? Whereas if you can be taking differentially private statistics around like bounded values or values within, within a particular range, or, if there's some structure that you can use, then you can make sure that the amount of noise being added on is going to be relatively small compared to the signal that you want to kind of calculate, right? So, yeah.
Yeah, that Boolean example that you gave, where if each participant's response is a Boolean, I think that was a very illustrative example of how essentially there's a maximal amount of influence that any individual answer can have.
Yeah, exactly. So, that's like there's case studies where people have tried to do this for like tax evasion stuff, where you ask a whole bunch of people, like, are you not paying the tax, man? Like, people don't feel too comfortable about answering that, especially if they are. So there was one experiment where, I hope I get the details of this right, but basically they surveyed people, but they said, have you been evading tax? But before you answer, flip a coin. And if it's, heads, answer truthfully. And if it's tails, just say you were evading tax or that you weren't or whatnot. And so that, like, no matter what someone's answer is, you can't like prosecute them based on it, right? Because you don't know which way that coin flipped.
Oh, that's very cool.
But there's still enough signal in there that you can actually get meaningful statistics out of it, to be able to like inform policy, for example.
That is amazing. It's sort of like the liar's paradox or the liar's dilemma, fed into a probabilistic model. Effectively, it's like, so I guess it's the idea of like, if you flip a coin, do you only flip a coin if you are a tax evading, or do you flip a coin either way?
I think in that experiment, it was like you flip a coin irrespective.
Oh, okay.
And then, but you could probably arrange, like, again, you would just have to think of the structure of like what the probability distribution is based on when people are flipping coins. And you obviously need to make sure that that you can give them a guarantee that they couldn't be prosecuted on that. And yet you can have meaningful statistics out of it as well.
That is, I think, that's just really fun and creative, and also, I guess, intuitive as well. Are there any more cool stories like that, or just like
there's
examples?
Like an infinite number of cool stories. Yeah. So like, there's lots of really famous stories as well. And I think, so most of my work at the moment, we really focus on input privacy. But output privacy is an interesting one as well. Like, this is the kind of what we've been talking about here. So there's like an example back in the 90s. I might get like the years or details this slightly off because I'm saying it off the top of my head, but there was someone called, I think it's like Latanya Sweeney, who was like a reporter in Boston. I think it's Boston because it was the Massachusetts group insurance company who had the issue. So basically, there was this she was a journalist who looked into this big insurance company that was selling information about it's like a data set where they had all of their patients is the wrong word, I guess, insurees, like medical procedures and like what drugs they were given and all the rest. They're like zip code, age, gender, ethnicity, etc.
What could go wrong?
What could go wrong?
Yeah.
Exactly. Yeah. And what happened here was basically what's now referred to as a linkage attack, right? So they were like, oh, but we don't have anyone's names. We don't have anyone's. We've masked certain information, and therefore it's safe to sell. I think even the governor at the time like really got behind it and was like, oh, it seems totally safe. And
no names, no problem.
Exactly, right. And for like, I think it was like $25 or something. Actually, one of the other guys in the group wrote up the story property, but for like $25, I think it was, she bought the like voter registration data set from Massachusetts that had everybody's name. They had like literally their names, date of births,
address,
they're registered, or an address, I guess.
Yeah.
Right? And from the two, you could just link it up. And they were able to spot a huge proportion of people in this list by just joining these two data sets together to be able to like get really sensitive information about them, including that governor who was like, oh no, it seems totally safe. So these are now referred to as linkage attacks. There's lots of great examples of this. One of the most famous, again, It was, I'm sure some of your listeners have participated in Kaggle competitions before. And there was the Netflix prize. Do you remember that? The Netflix
Yeah,
had
they
this
offered
big,
everyone it's like $1 million, and so it's enough to get all the like smartest like a lot of really dedicated data scientists to go and create the problem that, if you consider that any given data scientist, you could only get 10 data scientists to work on it with $1 million or less, by employing them. But if you offer them $1 million, you can get thousands of people to work on it. But yeah, go on.
exactly. But what's the caveat here? You have to give them
The
access
data.
to your data, right? So of course, what could go wrong? We don't have who our users are or anything like that. But little do they know that like what's going out into the big bad world isn't just the information which they reveal to people, right? Same way as with the insurance company, it wasn't just the information that they were selling that was out there. And so somebody combined that with the IMDb, movie ratings data sets. And they were able to connect the two. So for certain individuals, you could identify what movies they had watched based on when the reviews went up, etc., etc., because the dates were still there and all the rest. And they actually got sued because I think one individual, something came out about their sexual preferences based on like the movies they had been watching, and like they hadn't come out. I don't remember the exact details. I mean,
someone who wants to keep their sexual preferences private, as most human beings might want to do on some level.
Exactly. I mean, like this is your right. Yeah. Exactly. So, so obviously that information was not meant to be revealed, and it was. And so a lot of people are thinking now about how do we use privacy enhancing technologies to allow still create value from your data, but while actually preventing that data from being used for kind of like unauthorized activities, unauthorized access, and to be able to like protect it through that entire life cycle.
Yeah,
I have a friend who works in or worked in Airbnb. This isn't a comment by Airbnb themselves or anything. I mean,
we are not speaking for anyone other than ourselves, etc. This is not endorsed by any organization or business, etc. or data set. It's not endorsed by a data set.
You can think about the same problem for like 1 in a million different types of businesses, by the way. So it's a problem that people think about and they put in restrictions in order to mitigate the risks of, typically speaking, right? But one problem that they could foresee arising somewhere like Airbnb, let's just say, was that you've data scientists who are continuously trying to like, or in any company like this, who are continuously trying to like look at like user patterns and stuff like that and feed it up to the marketing teams, the sales teams, etc., in order to make the company more profitable, right? Like that's what a lot of data scientists do as their job. But what if data science A's like person A, them and their partner just broke up recently, and their partner is now traveled to Paris on like a vacation with a new partner or something like that. Like you probably don't want that data science.
Or 5 new partners, just make it as seedy as possible.
Whatever.
Yeah,
right? Like
a partner party.
Yeah, exactly. Like they can't. I mean, there's no way that data scientist should be able to have access to that information or to know about it, etc. And I mean, this happens for all different types of companies where you're basically saying like the activities of your user. Imagine like Uber or something like this, right? Or like any of them, the rental bike apps or something like that. Like, how creepy would it be if there was like some data scientist who knew how someone was cycling around the city and when they left their home and stuff, right? That's like safety risk 101. So how can you use that data to still be able to use it for like marketing purposes, or that's why you hire all the data scientists, but at the same time not have anyone be able to actually see the granular information through its life cycles? Can you do like eyes off data science where you get out insights that are valuable, you keep the data safe throughout its life cycle, still get value out of it, but you're not compromising individual privacy of your user base, and you use it as an opportunity to build trust and not to be opportunistic and like uncaring of the user base, basically.
Yeah, I was actually just thinking about the trade-off. Which would you rather know, that your recent ex is like partying down the Danube on a steamboat or something, versus so that's like the travel app, versus they did the bike app, and you realize what they're doing is they're just doing laps around their block again and again, getting really really healthy, and so they'll be fitter than you at the end.
While
Either
you're
one
still at
seems,
work. Yeah.
yeah,
No, but like, I mean, yeah. So I mean, it's always this challenge, and like, just even think about this, right? So, this is, I mean, this is a very well known story. I haven't actually read first reference of it, but I've heard it like a million times. So
it must be true then.
it must be true. Yeah, I'm sure I could find up the original source. But apparently, back in the day, in like the early 2000s, lots of people, dot-com bubble, lots of people were using Google. So they'd be sitting at their computer, Googling things, as we do every day now. And one of the smart engineers at Google said, hang on a second, right? If everybody is searching what they're thinking, essentially, and you're saying, like, your kid asks for a particular toy, right? So you're Googling it before the Christmas season or before their birthday or something like that, or you've had a terrible meal at, I don't know, your local restaurant or something like that. It's part of a chain. Maybe you Google like how to put in a complaint, or like how you got food poisoning, you need to like flag it or something like that. So every time you search something, that's not just in isolation. Like, how the internet works is you're pinging a server. That server is probably caching the information. Like, they're obviously answering the question you've asked, but they're also, there's gonna be some level of logging of what that information is. So people are asking frequent questions. Maybe you can respond a bit quicker, etc. But if you were to look through all of that activity, would you be able to just like own the stock market, right? Like, the new iPhone comes out. How many people are Googling for that iPhone and then like going from Google to the Apple website to go purchase that, right? If that number's high, Apple stock probably going to go up. If that number is way lower than usual, Apple stock probably going to go down. So could Google just be like trading and basically having a statistical arbitrage by surveying so many people at the event that they're doing stuff before like the wider spread stock market would find out? And as the story goes, they just shut down that idea immediately, because they were like, if we go down this trail of thought, there's going to be a million regulations and governance issues that are going to come in. Whereas if we're ethical, try to do good and not use that information, then we're going to have a little bit more liberties going forward. And we're already doing very well as business. So they didn't, apparently. But on Quantopia, because Google now releases their trends, but obviously they're like anonymized on macro and all the rest. And people have built models to kind of like back trade different stock markets based on Google Trends information, how people have been like Google searching things, and they perform like way above the stock market averages, etc. So that information, that's called query privacy. So if you were able to query an API and then not seeing what your queries were, then your queries will be private. Most of the time when you use a SaaS application, ultimately the SaaS provider can see what you're doing, right? So yeah, that's another one of these interesting privacy dilemmas.
That is really cool. And like, just getting back to the the Netflix example that you gave, where effectively you saw that just basically by what people were looking at, the timing and things like that, how they're able to connect these two data sets. You can imagine that when you bring IP addresses into this, where that's just a massive, like, presumably the challenge just even disappears, where you don't even have to, the technical challenge of mapping these things like disappears even more. So effectively, any company that is good, for example, Google Analytics, which they track your IP address, across different locations, and that's where they derive a lot of their value. That effectively, these problems can become trivial, technically speaking, with just a few extra bits of information. Is that correct, or is that tinfoil hat?
No. I mean, like, of course, like, the big companies know like everything about, like, but even your telecom provider, like, every time you make a phone call, every time you use an app and search on the internet for anything, like, it doesn't just happen, right? Like, your phone sends a signal either to the closest Wi-Fi box or like to the closest cell tower or something, saying, hey, literally get HTTP get the information from this URL. And even if that's totally encrypted, they need to know where to like send it to, so they can route your traffic through the internet.
Mm-hmm.
So of course they know like exactly where you are. Like just think of your telecom, right? Because you're connecting to their cell phone towers, of course they know where you are. Like they have to, otherwise they wouldn't be able to
Get it,
you wouldn't be able to receive a phone call, right? So that like they have to be able to do that to do their job. They need to be able to connect you to the internet. They have to be able to route your traffic. They have to be able to route all of your phone calls, all of your text messages. Like you're literally paying them every month to do that for you.
Mm-hmm.
Now, your hope is that what they do with that information is kind of aligned with what you would want them to do with that information. And they don't like kind of go off the track and start using it for like monetizing you in other ways and stuff. And like, I think when products are free by profitable companies, it's usually because you're being monetized in one way or another. So yeah, one statistic that I thought was like really interesting was if you were to read all of the data usage, so user agreements of all of the different services that you use online per year, it would take you 76 hours per year. So like that's like a full-time job for like 2 weeks for a lot of people. You just read through all of those like T's and C's that you like consent to when you go to use a particular website. So like we're signing up and like letting people use their data all the time. And I think that puts a big trust in these companies to actually, use that data in kind of like an ethical and secure and safe way.
Hey everyone, we're in the final stretch of our episode, and I'd really appreciate it if you could give me feedback on 3 things. First, what was your favorite question of the episode? What did I do right? Secondly, which questions should I have asked that I failed to? And third, what questions did this conversation bring up that you'd like answered in the future? Thanks, and enjoy the rest of the episode. One of the conversations I want to have in the coming year is with some of the data scientists who work for example, VPN providers, and essentially figure out the ways in which they work further to essentially help anonymize their clients. Because, essentially, I can't help but imagine that there are ways that they can help further anonymize and help preserve people's privacy that, the casual like observer like myself on this issue wouldn't be able to think of.
Yeah, sure. I mean, like, there's also, by the way, there's like Thor and Onion and stuff. Like, there's like applications that intentionally try to like hide like how people are connecting to the internet and stuff like that for those people who like really care about their privacy. But then again, like often, almost your interaction with these companies is you don't mind them knowing, like they play you an ad. You're okay with that because you're getting the service for free, and like, do you want to pay a few cents every time you Google something? Like, I think a lot of people will be like, yeah, just show me that little ad to the side of the page, it's fine.
Yeah, no, like I use Brave quite a bit, and so which I'm reassessing if it's worth the effort. But yeah, always there's that little pop up that they're what I appreciate about that though is like, versus like some of the Google ads where effectively you're going to see what you were looking for 3 weeks ago, or even like 30 seconds ago, in a dissociated ad, like on a dissociated website. Like, oh, you're on some flower website and it's showing me, the advertisement for, I don't know, like Warhammer 3. It's like, yeah, I see how you track me. But the things like Brave, what I actually like about it is when sometimes the ads basically have nothing to do with my interests. Like, it's like, you either are very good at tricking me or you actually aren't tracking me. So it's effectively having that dissociated ad hopefully means they're playing by the rules, or alternatively, they're flipping that coin and being like 50% chance we're going to show you something random, and that will lull you into the sense of security.
Well, like one thing I thought was like hilarious, and again, it's not, I mean, I guess it's because people are ultimately monetizing you, but let's just like not, I don't want to be a cynic towards all sorts of different things, but just obviously there's recommendation engines in the back of like, Netflix and YouTube and all these kind of things, because they want to show you things that you might be interested in, right? Even news recommendation websites do a similar thing. But I lived in Abu Dhabi for a while, and there was a guy from my old research group who lived there as well. We worked together in the same company. Like we spent like it was like we spent a lot of time together. And I remember like we would occasionally talk about like if we watched something in the evening or something like that. And he would tell me about something, and like the same day I would see it on mine, like as a recommendation, and then I would say watch something and he would, etc. And we decided that eventually, like, the kind of recommendation system algorithm in the background must have just like put us into the box as like similar person, similar interest, similar location, etc., etc. So we were getting like almost like a like a mimicked recommendation feed. But like obviously your behavior and what you're searching and watching for is influencing directly to what they're being recommended as well, because so that's how like your information is obviously being used in that context.
Yeah, no, it's actually sort of funny where some of these recommender algorithms, how they actually aren't very good at, they essentially have this either like overly discretized, or they're just really bad at sort of classifying certain people who have like a broad variety of interests. So effectively, the moment you watch, for example, one YouTube video, on, I don't know, it could be like marginally political, or it can be on economics, like how rapidly it tries to box you into just like, oh, you must be the wing of the most like dedicated viewer of this thing or that thing. And like I know that like I mainly get like a lot of like science and tech stuff spewed at me. But the moment I try to like get a little bit of news or something from like YouTube, it immediately just like, it's like a switching Kalman filter. It's like, you must be a lunatic for this. And it's like, yeah, this totally shoves you off in this other thing. And it's funny to see the algorithms were like burn its way out of that preference. I was like, okay, we're going to go back to showing you video game music and technical interviews.
So like I always thought one of the things, this has nothing to do with privacy, by the way, this is just like interesting things and statistics. But one of the things I always thought was interesting as well was like, determinantal point processes. It's like a kernel methods approach. Do you know this? I'll get context.
Slightly, yeah, slightly.
Yeah, sorry. I always think we're having a conversation, but I forget that's like people probably listening in. Like that.
Yeah, I'll pop up pictures as you talk about whatever you want to talk about.
Okay, sure. So DPPs, determinantal point processes, are essentially a dispersion model. So they push points away from each other. And so I won't go into the details of it. Essentially, you create almost like a similarity matrix between different things, different items. And it's based on like the eigenvectors and eigensamples, how you sample from it. And if you get a point in the space, the next point or any other point you're sampling, it's very low probability to be close to that point in the space, be further away. So people have used it for things like, news recommendations and stuff like that, right? Because, if you're looking at a news feed and there's an item from, I don't know, The Guardian or the New York Times, or whoever it might be, that's about topic A, but you don't want like your entire feed. Like this was I remember when like Trump was in power. Like I remember at times like my entire feed would just be about Trump. It's like, come on, like give me a break today. Time out, please, time out. And like sometimes you just want like different news from different sources.
Perhaps,
like,
for example, about your own country and what's going on there.
yeah, I live in a different continent.
Yeah.
But nevertheless, it's like you just want different things. And I always thought like I would really like if you could click into some of the like search engines or like YouTube's or whatever and just be like, please start recommending to me using schemes like this as opposed to schemes like that. I don't even mind paying a few dollars a month extra, but like if I hear like one opinion about something that's like, even say it was like political and it was like in one direction, like please tell me like the other opinion on this so I can have a more well-rounded kind of set of ideas on that, etc. But unfortunately that's not really how things work at the moment.
Yeah, no, it's like for me, someone who discovered dungeon synth music only about a year and a half ago. Yeah, it's like, it was all this video game and classical stuff that I was listening to originally. It took me a long time. I actually had to go through post-rock in order to eventually be recommended some dungeon synth. And what I'd like is just start popping random stuff out to me. Let me decide and let me and there could be you can just give them a completely nefarious reason to do it. Like, consider this. I'm not currently addicted to social media. if you show me the right thing, I might actually become a social media addict, and then I won't be able to escape your web. So yeah, you should at least be able to tell them, it's like, can you please do like either a reset on my preferences, like just forget me and let me just reset the algorithm, or alternatively, just as you said, essentially start giving me these like orthogonal or these more spread out results.
I remember my brother saying years ago, like, if you want to be the best golfer in the world, let's just say, like, if you want to be, whatever, let's just say golf, right? There's two ways you could potentially go about it. I mean, maybe there's many ways, but two of the ways you could potentially go about doing it.
One, be like, Tiger Woods. Two is what's the other one?
Absolutely, right?
Oh, really?
One is like, watch like every aspect of, say, Tiger Woods' shot, practice, try to get as almost exactly consistently to the shot that he takes, etc., etc. Or whoever the best golfer is. I'm not up on the best golfer is today, but the equivalent. Or the second option is like, just don't look at any of them and just like try different things and like figure out what's working and experiment a lot. Like maybe you might come, it's like optimization. You might like fall to like a local minima, or you might be able to explore. In Bayesian optimization, they call it like exploration, exploitation trade-offs. So explore the space, like don't be overly biased by the good examples you've seen too far. Make sure you sample other parts of the space, you might find something better. So yeah, it's like you kind of want, do show me things I like, but also explore and like help identify other things too.
Yeah, actually, that's that point is, it's something that I've taken for my own machine learning work, where like I know that some of the people who I've worked with, I kind of annoy them because I don't essentially try to really exploit the best known methods already all the time. Effectively, usually what I do is when I approach a problem, I approach from the ground level and figure out like, well, what would I personally do to solve this problem first? As opposed to like, what would Steve Roberts or Michael Osborne or David Clifton do to solve one of these problems? Is basically I just take it and say, well, what would I do? And the disadvantage of that is obviously if you only look at yourself, you don't get to take advantage of all the great minds who are out there. The advantage, though, when you do it that way is, one, it does cause you to think deeply, and also causes you to think within your own skill set about what you can do. So effectively, the solution you come up with might be optimal, given that you're the only person working on it. And so effectively, you aren't overreaching or misunderstanding some of the nuances of other people's work and misapplying it. So essentially like an incorrect inductive step where you say like, well, this person did well on this similar problem using this. And you make a false inductive step where if I use, excuse me, a similar method on a similar problem, I'm also going to have that same success. And I think that's an inductive leap, and it's not guaranteed. But yeah.
I totally agree with you. I mean, yeah. And I think you can apply this to a whole bunch of things. You can apply it to recommendation. You can apply it to your own personal research. You can apply it to work, right? I'm originally computer engineer, computer scientist. It's like back in the day, my undergrad was like engineering, and then you go to computer engineering, and then like went into machine learning, worked on privacy and security stuff, did a bit of work on like kind of ethics for particular machine learning approaches, etc. And I actually I think personally I found like if you like work on different things, you can then bring nuances from them together to like have greater impact. And that's kind of the exploration kind of approach. But I've seen other people who've had like terrific careers where they like got one thing down, absolutely nailed it, became like the best in the world at that thing, and then just like took it to town, just like applying it in different areas, but like that like very specialized thing. So
Karate Kid style, when you're the best around. Yeah. But yeah, no, the just maybe getting back to the privacy, because there's one example that you gave me that I thought was really cool and I thought might really appeal to data scientists. And you can just sort of it would help if after I talk about the idea, if you could just sort of resort it into the framework that you gave us originally, like is the idea that a data scientist might develop a model, and then someone might want to access that model, for example, via an API. But they don't want people to know what data they're feeding in. And they also, essentially they don't want to give somebody like an untoward advantage or something like that. They want to keep their use of that model very private. Is that
So?
Yeah.
Just for the viewers, I did not prompt you with asking that question.
No. But it is interesting, yeah.
Because we got a grant to work on that problem, essentially. So
that is kind of why, though, I wanted you to. You've been thinking about it. It's an interesting problem that a lot of data scientists have to deal with, because effectively, well, I think people can appreciate. Anyway, I'll get out of the way of the conversation. Can you describe the problem, where it fits in the framework, and things like that?
Yeah, sure. So it's always worth describing the kind of ideal functionality, right? Like how do you want this thing to work? And so, like, how you described it was, one person has a machine learning model, or maybe a bag of machine learning, or let's be even more specific. Like, they have a bag of computer vision models, right, that will take in an image and classify what's in the image, or something of that nature, right? You've trained a whole bunch of pre-trained models, and now you want to provide it to a customer, like through an API or something like that. And maybe they've got a bunch of data in the first place that's already labeled. So maybe you want to do a bit of fine tuning, or maybe you just want to give it, fine tuning, and then inference as a service. You give them predictions, they pay you money, or maybe it's just predictions straight out of the bag, but you want to make sure that you're giving them the best model, etc. And so it essentially, how you go about this is that you have this black box, right? This trusted execution environment, secure enclave, where one party uploads a machine learning model, and another party uploads their private sensitive data, and no one's able to get access into this. So no one can like SSH in and see, or read some log files or something like that. And so the person who uploads data, or sends a request to the API, wants to get back whatever's in the image. So the enclaves themselves, so this, the enclaves are kind of the core bit of this. This is what gives the guarantee to both the person who has the IP, the models, the computer vision models, etc., that are being uploaded, that no one else can get access to their models. They can keep their IP safe and secure, etc. And through the same mechanism, through the attestation documents, they can give the guarantee to the person who's uploading data that no one else, the other party who owns the API, can't see the data that's going through the model. But you might want to actually go a little bit further. And this is where, like, input privacy, so that what I just described there is an input privacy problem. People are inputting their data, they want to make sure that no one else can see it, etc. Where stuff like this can meet output privacy really nicely is that and this is where one of our grants came from, is that you may want to actually give back to the API provider information that's differentially private with regards to that person's input. So as they're sending up lots of data, or maybe they've sent up a batch of data or something like that, maybe you want to give accuracy statistics, or some set of metrics, etc., that tell the person, roughly speaking, how well is that particular model performing. Does it need to be fine-tuned? Has it been fine-tuned enough? Maybe they should switch there for another model, without revealing anything sensitive about the individual, like, records or images that are going through the system. And so input privacy and output privacy can actually work really nicely, like, hand in hand for these kind of problems. So that's work we're doing in collaboration with the Cedar Institute in Ireland, which is the National Institute of AI.
Yeah, cool. I guess we have a little bit of an input or output privacy issue with the questions I'm asking, because obviously we don't want to just like totally slant the conversation in a certain way with regard to Oblivious. Obviously there's that sort of third party aspect, but at the same time, it would be nice to sort of cover some of these, juicier ideas and examples, because I think it is of interest to a lot of statisticians and data scientists, the idea that when we're looking at sort of models performing metrics, someone might want to use your model. They might want to protect the data, but they also might want to give you feedback on that model's performance, so you can be updating and things like that, while still, giving yourself some level of protection. You can just imagine, like, a lot of trading algorithms, for example, where you might have somebody who's really good at, creating an entropy feature, and it's good to a point, but it might need, some not personalization, but some added precision due to a an individual stock. Like say people are wanting some feature and they're specifically looking at Tesla. And of course, now there's this added aspect where anytime Elon Musk tweets, that there's like an added entropy, like he is an entropy component. And, they might want to give feedback without directly displaying what they're up to. And, for healthcare, which is what I'm usually looking at, you can really imagine where you might want some state-of-the-art feature to be feeding into your own sort of data patient monitoring platform. But you sure as hell can't be giving them data of a certain nature. But you might want it personalized still. You could just imagine, for example, some type of irregular type of cardiophysiology, where you might have the world that's a really good leading algorithm that handles a specific type of physiology, and you want access to that, as in you can't replicate the model yourself. But you still want to use it, and you still want to give it some like updates and extra personalization on top of that. For example, accounting for demographics or like individual baselines and things like that. So anyway, that's sort of my example. Is that an apt example of?
Yeah, absolutely. I mean, this is, I know, I know often, at the end of the interview, you ask like, what's the big area that people don't often ask about. And I think that, and I'm going to answer that now. So spoiler alert. But I think honestly that people think of security and privacy a lot in terms of like an extra piece of bureaucracy they need to go through, like an extra tick the box exercise. And I think that is a kind of boring way to look at it. And it's at least what drove me to this space personally is like, what can you do now that you just could not have done before? And if you look at like entire industries, like one industry that's probably worth a lot of money if someone wants to set up a business is like, giving like third party like rating and risk assessments to these like huge funds and stuff like that. And currently there's only like a very small handful of companies who do that on a large scale. So they have done like a huge amount of analysis and they basically say, hey, show us your portfolio positions, etc. And then we'll give you a ton of like kind of unbiased third-party statistics and risk metrics, etc. that help you kind of understand your macro risk as like a pension fund or as a mutual fund or whatever the case, insurance company, etc. And why is there only a few number of very profitable companies that do this? Really, it's down to trust, right? So the incumbents have just been doing it for a very long period of time. So everyone kind of trusts them because they've been around for a long time. They have a ton of certifications. They've got, it's been their business for, maybe decades, etc. But like, who's to say that like new companies can't come into that space, or established companies who want to move into that space by offering new services in there? And now by like using, especially like secure enclaves and other tools like this, you can actually say, hey, listen, we can turn up with our body of knowledge. You can add to it all of the information from your side. You can get these really rich calculations out, great insights, etc. And you have a guarantee that we don't have a clue what you've gotten from that, what your side of the information was and what the outputs you've received from that is. And I think that like literally changes the game for so many different industries, right? Like that's one example in financial services. But if you almost look at so many different fields, especially, professional services, especially, I mean, you see this all the time with consultancy firms where they do work for like competitors, right? And the competitors are like, or each company is obviously quite careful about what information the consultancy firm will get before they move on and do work for their competitors. But what if they could actually provide services that were like real-time fraud analytics, etc., give best in class because they've been, learning kind of across the industry from it, but also that promise and guarantee that value created from that customer isn't going to be shared with their direct competitors. And once again, you can give those promises not through just a legal contract that says, hey, I'm not going to say anything at the coffee machine in the corner of the office to my colleagues. You can actually say like the infrastructure just does not permit that anymore. And I think that like there's just huge opportunities for people who are interested in maybe setting up businesses or innovating within their businesses to have like new trust relationships and hence new technologies and new value by leveraging pets. And I think that's what's like really exciting. What can you do new? Not how can you do the same old stuff, but just a little bit, safer or with better tooling, etc.
Yeah, I think it'll definitely be fun in the coming years to essentially hear the success stories and obviously the failure stories as well, but like places where people have succeeded using these new capabilities and seeing what's possible. The magnitude of innovation, and also get an idea of the specifics about what it was exactly that allowed this to work. But yeah, I guess for our final question of the day, and this is one that I ask everyone: what is a question that you would like to see data scientists or statisticians debate?
Okay, that is a good question. Yeah, I mean that's a really good question. I think one thing that often comes up is kind of, so for a lot of the privacy enhancing technologies to do their job, you kind of need to know what you want out of it to some degree. And also there's different types of technologies which you can use which have like different constraints. So for example, secure enclaves, if you're using AWS Nitro as an example, to some degree you're implicitly trusting the infrastructure of Amazon and the certificate chains that can be created internally by them, etc., etc. If you use multi-party computation or homomorphic encryption, sure, there's different constraints on the ground in terms of like maybe you don't need a third party at all. You're just encrypting the data in a certain way, but there's a lot of extra packets going back and forth between parties, etc., etc. But what I mean, like what I'm trying to get at is, what do we actually want to see that give people confidence and trust that data is being used responsibly? So, like for example, you're seeing a lot of open source libraries that are coming out now. OpenMind, fantastic group. They're a huge community who are developing tools that are open source to allow people to do data science. And everything is open source. They have some fundings, they have some employees, but a lot of it are also contributions from like the wider community. For multi-party computation, you get like ABY that was developed by an academic research group in Germany, etc. You've got, there's tons of them. I won't go through the entire list. When you go totally open source, you basically have little kind of support and guarantees. And there's definitely pros because you can get a lot of eyes on it, but also some of these communities are still quite niche. There's not that many eyes on them. So there's like risk and reward. When you go down to kind of like enclave-based approaches and whatnot too, you put a lot of trust in the cloud providers or the chip manufacturers who are building these things. Where do we draw the lines around what we're willing to trust and what we're willing to not trust? And how does that change depending on context? I think that's the real question. It's worth thinking about. If somebody says, because with a lot of these things, it's not good enough to just try your best, right? Like to say, hey, we tried to be respectful of your data, we processed it, and whoops, it actually leaked. And a lot of people, it's private personal information is now on the internet or something.
Yeah, we tried to drop the name and social security column, but
yeah, we didn't, or we did, but from the other information, like I think you need 4 geospatial and temporal credit card piece of information from people use their credit cards to like uniquely identify them. So like you really don't need a lot of information to be able to know a huge amount about an individual. So you have to be like quite careful with that. And it's one of those areas where the outcome is so important, not the process. Like the data either was protected and safe or it was not. And it's not necessarily just people's goodwill and intentions. That is the important bit. But having insight, and it's one of these areas as well, because privacy enhancing technologies are still relatively new. There's a lot of best practices that are coming out. There's a lot of like guidance materials. There's different ISOs that are being written, etc. And sometimes some part that's like missing from a lot of these conversations is actually like conversations with users, both users of data, and often you get into like the data rights kind of activist type people who kind of represent like users' data generally. But you also need like insights from statisticians, like what are their requirements, what do they trust in, etc. You need insights from security engineers. It can be down to like usability. When you bring out these different tools, how usable are they, right? Can you actually use them in your work or not? Because if you can't, it's not really that useful, right? And so I think getting more feedback and more ideas from the users and from statisticians, etc., about what they trust, what's important to them in terms of a usability perspective, etc., is like, I guess it's not really a debate, but it would be incredibly useful for the like pets community to understand better. It's not just ourselves. I mean, like we try to collaborate with like a lot of different open source communities and a lot of different other companies and all the rest. And I think everyone's always asking the same questions. Like, we want to make biggest impact, we want to be helpful and all the rest. But what are the caveats, constraints that you really care about that will make your life easier, your job easier, or you think you would like your data to be manipulated with? What are those constraints, and maybe formulating them and getting richer ideas around what people are comfortable with? That would actually be really beneficial to the entire field. So people just thinking about these things, discussing them, maybe writing a blog post or getting involved in the conversation, I think is super important.
Great. Cool. If you don't mind, actually, I will break my rule and do one follow-up question because I noticed, you're talking about like usability, and at the beginning of the conversation, it sounded like you had talking about utility versus usability. I was wondering, is that an actual? Is there a definitional change between those things, or was that?
Sorry, earlier I meant to say utility versus privacy, like how much you hide information versus how useful the information you extract from that is.
Okay, cool.
But I also meant at the latter part, it's like a lot of programs, like let's say multi-party computation, a lot of those tools, like cryptography frameworks, are written maybe like very low level C or Rust. Now, I could be wrong, but at least a lot of the people I would know from the machine learning statistics community aren't necessarily going to like rewrite a whole bunch of NumPy into those low level building blocks, or like take an R program and try to refactor it. Like that would be a monumental feat for them to be able to get around. So, but I'm sure there's a lot of open source developers, there's a lot of companies, etc., who are willing to try to like bridge those technologies. There's a company in Paris called Saris, and they created a differentially private version of XGBoost, right? So all the XGBoost users can potentially learn a model that's differentially private with respect to the training data in XGBoost because of them. But Facebook brought out, Facebook and Google, they both have similar ones. This for Theano and TensorFlow. This TensorFlow Privacy, and I think it's called Octopus or something, which is the Theano version, which is like if you have neural networks, how do you train the weights so that looking at the weights doesn't give away anything about the training data that got passed through. So these are attempts of people trying to bridge privacy enhancing technologies back to statisticians, machine learning scientists and engineers can use and take advantage of in their daily practice. And like greater feedback between those two communities is going to help improve both fields massively, I think. So getting people involved in design and feedback, etc., is incredibly important. And hopefully tying those two communities closer and closer together will ultimately make like the tools of tomorrow more feasible.
Thanks again. This is Jack Fitzsimons of Oblivious AI. Thanks for coming by today.